So welcome back from our little break. And as I have promised, we have another Sebastian in the room. And he's now up and will essentially continue the journey Juliette started today, because he's talking about unmaintainable code and will give us an insight of his open source day of life and how to write unmaintainable code, something I think everyone in this room can relate to, because probably everyone has written unmaintainable code or code they looked at and thought, oh well, who wrote that shit? Well, that was me. Okay, so give it up for Sebastian.
Let's see if the mic works. Yes, now it does. Hello, everybody. Nice to be here, and I'm really happy that you all found the way, despite the elevator being broken, so thanks for taking the stairs. So I am Sebastian Kurfürst. I am one of the founders of the web agency called Sandstorm here in this building, and I've also been a Typo 3 core dev a long way ago, and I've been a Neos core developer since its inception, so I'm doing open source since I think more than half of my life, actually. I'm getting old, actually. I'm having 2 kids right now. I'm 36 years old. It's always difficult. Last year, I always explained, I'm 34, and I was like, oh no, actually I'm 35. No. So I'm always thinking, 1 second. And I do web applications, as most of you probably do, with lots of different stacks, so mainly based around Neos, Flow, Symfony, Laravel, but also Java and Golang. Also front-end stuff, TypeScript and React. And as a pet thing, I do a lot of high scalability things, so that's where I'm really eager to do things. And so I asked myself, okay, how do I actually write unmaintainable code? I mean, I do it every day, same as some of you maybe. So how do I actually do that? Let's just Google it. And it turns out if you Google that, click the first link, you get a really, really good document. It's called How to Write Unmaintainable Code by Rudy Green. Does anybody know that? No? Okay, then it's getting good. Because it's a long, long, long document. It's nicely structured. It's, for instance, structured into naming. And it says, much of the skill in writing unmaintainable code is the art of naming variables and methods. They don't matter at all to the compiler. That gives you a huge latitude to use them to befuddle the maintenance programmer. And then the list goes on. For instance, they say, please use names for babies for naming your variables. Or, you know that PHP can do a Unicode, do you? You can actually use accented letters in variable names, and that will work in PHP as well. You can use emojis and try to find a difference between I and I are good. I'm not sure, I'm not French, so that's getting difficult. And if you open that up in VI, it looks almost the same. Please use misleading names. So every method should do a little bit more or less than the name suggests. For instance, a method named isValid should, as a side effect, convert X to binary and store the result in a database. But let's just think about that. I mean, it looks like a funny example, but didn't we all do that in the last 3 weeks, maybe? You know, we had this method which had a clear purpose, and we just added this little detail because it fitted so well. So I personally do that all the time. And it's hard to not do it, actually, because it's almost what we want, but just almost. So that's the point of this talk. So I asked myself, how do I actually write good code? What actually is good? And it turns out, if you ask this question to a bigger audience, some people say, well, it should be readable, it should be reusable, it should be consistent. Who agrees with me on that? Yeah, almost. Who does not? Okay. But then it's difficult what this actually means. And for instance, things we are not so sure about is, should the code be English or should it be German? Or should we have no comments or should we have lots of comments? Should it be dry or should it be Yagni? So don't repeat yourself or you ain't gonna need it, you know? I'm pretty sure that we will have pretty differing opinions on that. So defining what actually is good code is not easy. But if you start thinking about this process, then you're actually doing architecture. And that is a thing you should do really consciously, I think. So if I want to talk about how I do architecture, I have to look back and I have to reflect on how I started programming. And for my personal journey, we have to go back around the year 2000. If you go back to the year 2000, an unknown British band named Coldplay released their first album. In 2001, this device was released, and it's not the iPhone, by the way. It's the one before. And this first film came out. Do you remember that? Yeah, a few. And 3 years later, in 2004, this guy put on this website called Facebook, and this is how it actually looked like. You know, this dotted outlines and these buttons with the shade. And this creepy guy in the corner explaining what he's doing. Yeah, it's a bit awkward to look at, I agree. And for me personally, my parents also worked in IT, and in the year 1999, my first conscious memory of IT was actually that I was 11 years old, and I was at Infineon, which was back then called Siemens, at the parking lot, because there was this year 2000 problem. Do you remember that? It was basically the point in time where well, basically nobody knew what happened because year numbers were often stored in 2 digits, and in the year 2000 we would have an overflow going from 99 to 00, and nobody was like, what is actually going on? And a lot of people spent a lot of effort to actually get the system or keep the systems running, and it was my mother's job to keep to keep a certain part of the factory running up there. So actually we were back there. And looked, and nothing happened. I mean, that was a good thing because it was so well prepared. It actually went really smoothly, but it could also have happened quite some bit. My programming jobs back then were, of course, a lot easier. I started programming in MS-DOS, like alle meine Entchen, with this beep of the computer, because you didn't have a sound card. You could just do something like make 440 kilohertz sound, or hertz. I think it's the A level, and these kind of things. And of course, my focus was to get it running, right? This is what you do when you do your first steps. You do just a small piece of code, and as soon as you get your job done, you get this adrenaline rush, and everything works out, and that's really cool, and you tackle the next problem. Then a few years later, in 2005, I was 17 years old. I became a Typo 3 core dev. And I was also really focused on making things work. I wanted to ensure that all the edge cases were covered. I didn't think about architecture at all. I was trying to do as bug-free software as possible. And the Typo 3 system has grown a lot. It was not architecture, it was just organically grown, basically, like most open source software at the time, right? And back then, we saw that Typo 3 was used in a lot of places where it was never intended to be used. So it was used as an application framework, although it was a CMS. And back then, it was even more a CMS than it is today. So that's why we as a core team started with a framework to cater to the needs of our users, which has later become the Flow framework. And because we had the chance to start from scratch, we were able to do lots of architecture decisions, but it means we also had to take lots of architecture decisions. And my main influences back then were 2 books, actually these 2 books. Does anybody know them, the left one? Yeah. So the left one is Patterns of Enterprise Application Architecture from Martin Fowler. It's basically a book which is explaining design patterns for bigger applications. So it explains stuff like MVC, like two-phase commits, how to work with databases, and so on. So it's like design patterns, but on a more broad scale. And in fact, this book has aged very well. Of course, it's not all true, which is stated in there, but still, if you look at a book which is like 22 years old by now, actually it's still very readable and very useful to read. And the other book, Domain-Driven Design, who knows that one? A few ones. Who has heard of a repository? Oh, the same? Okay, so the wordings, if you look at Doctrine Framework, for instance, or Symfony, or Laravel, lots of the wordings actually span from domain-driven design. So domain-driven design is is actually a process or a way of modeling real-world problems into software in a very specific well, stepwise manner. And the good thing is that it's applicable to any problem domain. It's really explaining to you, or it gives you a set of tools how you can model any part of the world into software. And it's also a really good read. Actually, I reread it like 1 year ago, and I was still very, it was interesting how much things I overread when I read it the first time. So it was really also really well, very relevant today. And back then, there was Eclipse framework. Does anybody remember this thing, Eclipse framework? Yeah, a few ones? Or the Eclipse UI? And they had this thing, yeah, OSGI, it's very easy to get started. 45 minutes for the getting started tutorial. And this is just an excerpt of the getting started. So it's really, really a lot of effort to get into it. So that's where Spring was found. I founded the Spring framework, and it was actually a contrary movement to the Java enterprise world you have probably heard about. And back then, when I started, my goals were less lines of code. I would like to have self-documenting code, and I would like to work with objects. And this is what we tried. So in Flow framework, for instance, we had this idea, it's an MVC framework, and we had this idea that you would like to work with objects all the time. So for instance, this is a listing of blog posts, for instance, and there you actually pass in the full object, the full blog post object to the link, and the system internally figures out that actually you would like to reference it. It will add the ID to the URL, and when you fetch the thing in the action, you again can imagine that you get the full object right from the start, and the system automatically fetches it from persistence. So it was objects all the way down. And for editing posts, it worked somehow the same. So you had, in your edit action, you get the post, you assign it to the view, and then you could bind the full object to the form, and you would get the same object then in the update action. And the good thing was, this handles all kinds of redisplaying if there is an error. You know, if you mistyped anything, you had to re-show the form. The old values will be shown, the highlights or the text boxes with the errors will be highlighted. So this is all handled automatically by this framework. So actually, it made me pretty happy when we built that because, yeah, we reached our goals. But it turned out where there's light, there's also shadow. It was still pretty bad code internally in some parts, especially one part which is responsible for this conversion from objects to simple types and back. It's called a property mapper. And the property mapper is it's actually, I created this whole thing. It's what I would call today a Jugendsünde. I'm not sure what the translation of that is. So, a sin of my youth? I don't know. Well, and the property mapper says it transforms simple types to objects or other simple types. It is used most prominently to map incoming HTTP arguments to objects. And it turns out there's two words in here which will become a problem in a few seconds, which is most prominently. Well, it turns out the property mapper defers to a thing called type converters, which is a really good idea in general, but it's really hard to use. And you already see that when you look at the comments of something. So this is the part which converts arrays or strings to persistent objects, and there's a certain logic to that. And you don't need to read that, but you already see from the documentation, there's a lot of cases, it gets hard to describe what this thing actually is doing. You know, it's getting more and more and more complex. And if you look a bit further away, then you find something else, which is like, well, a converter which transforms various types to arrays. So, and then you can do stuff like, if the source is a string, it is somehow parsed as CSV or JSON, and if it's a resource, it's embedded as base64. Why the hell? You know? It is, but the reason is, it is because the property mapper is used mostly for converting from HTTP to objects. That's the other part of mostly. It's the remaining 5%, and that's the part where the problem starts. So the thing is used for more and more scenarios, and this leads also to things like the persistent object serializer, which is now used for the opposite direction, so from objects to strings, which is of course not at all what it's intended for, but it was just so little to write to make it work, so people did it. And I think I'm the person I did it probably. So it was used for more and more scenarios. And it has some benefits. It still today has some benefits because by that we are able to prevent lots of security issues. So in Flow Framework, by default, there's no SQL injection, there's no CSRF, because we are able to do all that automatically for you. And that's a huge benefit. So we saved our users from lots and lots of bugs by the way. But it also has lots of drawbacks, of course. And you might have an idea of the magic going behind the scenes just by looking at the comments together with me. So it's really difficult to follow. And the last point, it's extensible, but it's not extensible. What do I mean by that? Well, actually, it is extensible. It's extremely flexible and extensible, but only if you know exactly what you're doing. Only if you really know the intricacies of the system in detail, and it calls itself recursively, and this is where it starts getting difficult. So I think there are probably, by today, there are probably 50 people in the world who really understand it. And like 2 years after we created, there were probably 5 people in the world who really understood it. So that is a huge problem for an open source project, obviously. So today I would take a different stance on my goals. So that means instead of less lines of code, I value explicit lines of code more. In terms of self-documenting code, I would actually like documented code. Wouldn't that be cool? And instead of just saying, well, I would like to work with object, I would like to work with immutable and functional patterns. And we get to that, what this means in a bit more detail. Right. So as we've seen by now, on my personal story, we've basically seen how you start creating things with good intentions, and then still there's a certain chance that some parts turn into a mess. And that's just the way it is. That's nothing to be angry about. That's just the way software development also works to a certain extent, I think. So what I would like to do now in the second half, I try to distill some elements of maintainable code, which we can talk about now. And I think this is probably useful, hopefully, to many of you. But the interesting thing is this is just the tip of the iceberg. It's the parts above the surface which are conscious in my head, which I'm right now able to talk about. So I think in 5 years from now, I might look at the world quite some differently, more nuanced, and that's just the way it is, and that's a good thing, I think. So that's just a snapshot, basically, where we're going into. Right, so let's try to create good code. What would I say? How can I do that? Well, basically, compact code is pretty good, I would say. I don't want like an introduction taking 45 minutes and creating 50 classes just for creating a calculator or something like that, you know? And that was like OSGI was done in the past. But on the other hand, I would say explicit is better than compact, and clear is better than magic. So that means I would say things can have a few more lines if that makes it more explicit what's actually going on, and if it reduces the magic of the system in general. And magic is just generally speaking the parts you don't understand when looking at it, right? So the key question I'm asking myself today is, what do I need myself to understand the code in 3 years from now? And it turns out this will guide you automatically into a certain direction. And one thing which will guide, or which guided it for us, for instance, is intrinsic similarity. So that means naming for me is something important, but consistency is even more important. So that means the structure of the code in terms of classes, in terms of modules, in terms of the internal structure, should be somehow consistent, and it should be like fitting towards the rest of the system. So if you would like to put it a bit more bluntly, you could say, well, new code should be written the way old code was, right? I would not like a situation where you look at some code 3 years from now and then you say, oh, well, that's a Kurfürst from the year 2004, and that's Christoph Dehne, one of my colleagues, from 2015. You know, it's not like a painting where you can say, oh, well, that was the early phase of this person. But the ideal code would be you would not be able to see who actually created it because it feels intrinsically consistent, coherent, understandable if you open it up. And what this means in detail is something we have to figure out collaboratively. So that means we as a team creating things have to decide and discuss what this means. And if we decide on renaming something or restructuring something, then we should do it swiftly and just, end up again with a new consistent and coherent structure. So that's not the excuse for not refactoring, just to put this really clear. Right. The second important thing which reduces complexity is immutability and pure function. Who knows what immutability is? Yes, quite some. And pure functions? Also some. Okay, just some recap. So immutability basically means objects won't change. The state in objects will not change. So you could roughly say you don't have any setters. How does that look in practice? Well, instead of, so this is a class from Neos now. It's first and foremost, it's final. You cannot extend it. Second, it has properties which are all public and immutable themselves, so you cannot modify them intrinsically as well. And we usually do a create function, so we make the constructor private because that makes it possible to extend that, so you can create multiple factories for that, and you're not limited to the number of arguments your constructor had, so that's basically a preparation for future extensibility. And then we have all the methods like get and has and equals. And if you would like to create, if you would like to change something, you would rather create a new object, which is basically a copy of the old one with the replacements you would like to do. And if you do that consistently, you get a lot of benefits. The first one is objects will never change. Never, never, never. They are easily comparable, and they are easily composable. And what do I mean with composability? It's basically like Lego bricks, at least like the Lego bricks I'm used to know when I grew up. So meaning they fit together really, really well, and they are designed in a way that you can, for maximum flexibility, basically. And you know that they all fit together. And this brings me to the second part, which is functions. So pure functions are a special, or functions with a special property, which means they have no side effects, they are deterministic, so roughly you can say, given the same input, they will produce the same output. So that means a function like adding something is pure, so all the mathematical functions you're used to are mostly pure, I would say. A function which is not pure, for instance, is something like which outputs the current date, because all the time you call it, you get another date. Another function which is not pure is a function which sends an email, because that is a side effect. It modifies a part of the system, of the external world, for instance. This is all not pure. And why is that important? Well, it is important because if your data is immutable and your functions are pure, you can play Lego. You can compose your functions to create bigger and bigger and bigger systems without having these nasty effects that an object changes in the middle for some reason or these kind of things. So this reduces complexity a lot. And it allows you to create something like processing pipelines for your data. And we've been doing that in Neos for the last few years, and this has been really, really helpful and successful in building large systems. So that is something I can really recommend, and we also do that in our customer projects usually. So my recommendation would be actually, please learn some functional programming. And you don't need to learn about monads or anything like that. You don't need to buy a functional programming book which explains like I personally actually don't know what a monad is. I mean, I've learned it for maybe 5 times and forgot it 4.5 times already, so I don't really know. But I think what is important is stuff like filter or map or reduce, so the functions from JavaScript or from PHP as well. And the general idea of taking a big problem, sliding it into smaller problems, and then solving the individual problems, and then building up the big problems again, or the big solutions again. So this is called divide and conquer. And this is fitting very much together with immutability and pure functions. Right. Next topic, libraries or frameworks. Who has created a framework in his past life already? Also an internal one, not just a public one. Yeah? Who would do it again? Some, okay. Who has done a library? Also same, okay. What's actually the difference between a framework and a library? Does anybody know? Dependency, yeah, exactly, that's the good direction. So the difference is, if you create a framework, or let's start with a library. A library is basically, it's displayed on the left. It's basically, you have your code and it calls into the library at various points in time, and it will use the results of the library. So that means a library does something like logging or sending an email or doing a really specified functionality block. And the opposite is a framework. A framework is something like Laravel, Symfony, Flow, for instance, Spring, CodeIgniter, and whatever frameworks you might still imagine or remember. And the difference is that the framework controls the bootstrap. And it calls your code at certain points in time. For instance, when you create a controller, that is one way of where you can put your own code into the framework. And a good framework today has lots of these places where you can hook into, but it's very specific to the framework itself. And the framework, or the difference is, a library has no dependencies on the environment, or very little dependencies on the environment, versus a framework has lots of dependencies on the environment, because it is built to manage the environment. So I would say today, frameworks are really good and important for things like wiring, configuration, dependency injection, logging, these kind of things. Go ahead and use them. But please do not couple your business logic to the framework. And this is an error I'm seeing again and again and again. You know, you look at some business logic and you directly know, oh, well, this is a Laravel thing, because it's so much tied into Eloquent, for instance. Or it's a Spring framework thing, or a Doctrine thing, and you see, well, the business logic is so much tied into Doctrine. And the problem by that is you reduce lots and lots of flexibility in doing that, and it basically constrains you more and more and more, and at some point you will only start to, for the last 20%, you will only start fighting the framework again and again. So for things like, I don't know, who uses Symfony? Probably quite some. And on Doctrine? Yes. Who has ever fought with the Doctrine ORM? Okay, so some. So the Doctrine ORM is a really cool software which is an object relational mapper. So this helps you to take your objects in the database and pull them into memory representations, so objects you can work with. And the good thing about Doctrine is, and any ORM is that it tries to do this as transparent as possible. And it is a really, really clever idea on the first sight, but it turns out it's just very difficult to do right, and it's not possible to do right, I would say, today, because a framework like, or something like an ORM tries to hide from you that you're working with SQL, actually. It tries to make you feel you write PHP code and not that there's a database behind that. And that is, I think, a leaky abstraction. And there's no way around that. You know, it's not because the writers of Doctrine are too stupid. They are not. They're really, really clever people. And I would say, if you need to use an ORM, then please use Doctrine, because it's a really, really good software. But I would try to avoid that, because it solves a lot of, or it avoids a lot of domain-specific problems. And the interesting thing is, if you look at frameworks today, they have converged a lot on the same feature set. So there's no difference in using Laravel or Symfony or Spring or Neos on Flow, for instance, because they pretty much provide logging, configuration, dependency injection, and there is no need to create another one, because you can just use one of these, and that's totally fine. And your own custom code should live in libraries. Right. Next topic, tests. Sebastian Bergmann has just talked a lot about tests. Who is testing, who is writing a test case every day at work where he's coding? Okay, maybe 20%. Who is doing that every week? Okay, less people than just now. That's interesting. Okay, who's doing that every month? And every year? Once a year at least? Not everybody? Not one test case every year? Okay, the thing is, we have in our company, so our company exists for like 17 years right now, our quality is very important to us. And we have had lots and lots of discussions about creating tests. And we were always like, yeah, please create tests. And then developers were coming to us and saying, well, how can I have the time? I don't have the time to do that. It doesn't have the priorities. And we were actually saying, please do it. But still, it didn't work. It just didn't happen. And then it dawned to us that actually establishing, creating tests needs a big cultural shift, right? You need a shift from let's get it done as quickly as possible, and then I can start with the next one, to actually the tests will help me maintain my speed as soon as I have a certain number of them available. And that is what you need to experience to understand. And I'm personally having the same problems as everybody when I start a new project and I don't have any tests yet, I don't have any fixtures yet, I don't have any setups to test. It's like, oh, now I need to create my first test case. Oh God, it will take me like forever, you know? It will take me forever. It's like, you would like to continue with the next feature, and now you still need to do the testing. And the first test is so painstakingly obvious what you would like to test. It's like testing Hello World, right? It's testing the assert functions in PHP unit. It's something where you say, yeah, of course, that's one line of code. This will not break. But the thing is, if you start with these simple tests and then you gradually expand them, at a certain time, you will have a base where you can do lots and big refactorings very, very easily. And in Neos, for instance, in the new content repository, which we are rebuilding since quite some time, there's a big code base and a lot of test cases, and this allows us to move really, really fast because the tests save us all the time. So this is what I can really recommend. And it turns out that by now, we were able to do this cultural shift in our company, so most people write tests as of now, and they also use it without us telling them to do that permanently, because they all experience themselves how useful it is and how it is possible to speed you up and to catch regressions again and again. And this is the understanding everybody has to do, I think. Because testing, and especially end-to-end testing, really speed up complex software development. Right. Then there's one topic called for reducing complexity. Who would agree that this is a good idea? Okay, almost everybody. Who knows how to do that? Yeah, difficult, right? So for me, I wouldn't have had a way to explain what I actually mean by that a few years from now. Ago, but then I found a really good book, and I promise it's the last book recommendation, if I remember this talk correctly. It's a philosophy of software design by John Osterhout. It's just like 120 pages. It's not really long, but it's really, really good. And it's about complexity. And the definition they say is complexity is all parts of the software which makes it hard to understand or to change it. So that's the two aspects. And it goes further and says, the root causes of complexity are dependencies and obscurity. And dependencies is, well, that's the dependencies to other software, other frameworks, other components. So it's basically how interconnected your components or your modules or your software is. And obscurity is just how much magic there's in there, basically. So everything which blocks you from opening up and directly understanding what's going on. And the book continues in explaining how you can reduce these two things. And one metric they have created, or one idea they have framed and phrased, is the idea of deep modules. So what is that? So a module can be anything like a class, a collection of classes in a folder, a composer package, right? And even a small function, a pure function, is also some kind of module. And a module always has some kind of interface, so that's the part which connects to the external world. So in terms of a function, it's the parameters and the return types, and the side effects, if it has some. For classes, it's the collection of that. For modules, it's even bigger, and so on. And then you have some implementation behind. And the idea of deep and shallow modules is the ratio of the interface versus the depth. So how much the module is able to hide from you. I'll give you an example. So there's a module like, or let's imagine some API where you upload an image and the system says you what is on the image, right? It explains you, well, there's somebody having a talk on a conference. It has an extremely small interface. You pass in some binary data and an image and you get back a string which explains what it is. And I have no clue how it works. So that's the perfect example of a very, very deep module with a really, really small interface. On the other hand, a shallow module is what we usually create when we don't think about these kind of metrics, because our modules tend to flatten. You know, this means our classes get bigger, they have more dependencies, more packages which they are using internally. So things like controller classes are usually shallow, right? And if it's really difficult, they are both shallow and deep, so that means every logic is put into your controller, then that's basically the worst of both worlds. You have a big, big surface and then a lot of functionality underneath that, which is not coupled very well. But the idea is if you can try to make deep modules, because they reduce complexity and obscurity. And you have to remember that modules always try to, well, basically, breitfließen. I'm not sure what the English word is. So basically, they always expand on the sides because it's always easier to add new things than to keep the implementation concise and rather not add this extra parameter to the method for a certain case. It's something you need to do consciously, but it pays off a lot if you do it consciously. And if you need these shallow modules for some reasons, please document them. And documenting, I've thought a lot about documentation in the last years. I would say if you have to choose what to document, then please document the why. And there's this guy, Antires, Salvatore Sanfilippo, exactly, the Redis developer, the original one. And he has a really good blog in saying, writing system software code comments. And there he explains a bit about design comments and stating why a given piece of code uses or works in a certain way. It's a higher level overview of what you'll see implemented in code, and so on. With such background, reading the code will be simpler. And you tend to trust these kind of code more if you find these kind of comments. So the idea is don't explain what's going on, because that's the same thing which is already in the code, but try to give context, explain why. And like the rule of thumb I'm giving myself is every class either has a why comment or has a link to a why comment. So that means with at most one hop, I would like to be at the why comment. So that's what you see on top. On top, there is some why comment with an API comment, and in the bottom, there's an internal annotation, but you directly know where to look for to get this context. And this will speed you up tremendously in the upcoming years and months. And I also put in lots of sketches and diagrams into my comments. I'm a very visual person. I personally use a Mac software called Monodraw for that, but that's really recommended to just visualize what is going on. And of course, it takes a bit to come up with these diagrams, but usually I personally end up with a more clear model in my head what I'm actually developing. So this also pays off, especially if you have to touch this code ever again. And please write some concepts. That is also a good idea. What I mean by that, actually concepts are really difficult for me to write if I start with a blank sheet of paper, you know, because it's like, where do I start, where do I end, and so on. There's a good documentation by Basecamp. It's a good book called Shape Up. And there in the middle, they have these ingredients to include in what they call a pitch. And this is a structure. It's a problem statement saying, what do we actually want to solve? It's an appetite, which says how much time do we want to spend and how it constrains the solution. That's important. It's not an estimate. It's not asking the developer how much will it cost. So it's asking the business how much are you willing to spend for this problem. It's a totally different angle. And this will frame how you will end up with the solution. Then you have the solution. That's probably what most people think of if they think of a concept. And then it's about rabbit holes and no-goes. And they are sometimes optional, sometimes not. But you see that actually the solution, the part you typically see as a concept, is just one of a few points. And especially the problem statement is extremely valuable because it guides you towards a good solution. And we are a very code-driven company, so we usually store that right in Git next to the source code in a big folder called nodes or docs. And they all have a date, and then via Git you have the author, and this is all we do, and this is working actually really well. And some things are really short, like this is a full concept on the left side, so that is a very, very short one, but it covers the relevant information, which is how we deal with secrets in our Ansible repository. But then some concepts are really, really long, like you see on the right side. And don't worry if the concept is incomplete. That might be also okay. It's a lot better to have an incomplete concept than to have no concept at all. And today, most code I am seeing actually does not have a concept. And that is something I would like to change. And the last point is please review and discuss. And by that, I mean not just doing this asynchronous code review everybody is doing, you know, in GitHub or Bitbucket or however this tool is called, and then you say, oh, well, this comma is at the wrong location, usually, or please fix the white space, but rather sit together in front of the same screen and discuss the code, explain the code with each other. And this is how I personally learn a lot, and we as a team are quite effective in spreading your knowledge. This is much more effective than just looking at a random review in an asynchronous way. So, to sum it up, what we did today, first we did this unmaintainable code part, and then we tried to flip it around, talk about what is actually good code, how can we measure that, and what are elements for maintainable code. So we had this intrinsic similarity, we had immutability and pure functions, the idea of using libraries over frameworks, of creating end-to-end tests, or tests at all at least, reducing complexity by building deep modules, documenting why, writing concepts, and reviewing and discussing both the concepts and the code. So, thank you so much.
Thank you, Sebastian. So you know it. I will ask you, do any one of you has one or two questions for this Sebastian? If not, he will be in this room at the back and all the day. And if you want to ask him about this talk or about the cameras, the lightning, what happened to the PHP developer day, he's the guy you should ask. So maybe we need a break if everyone is so silent right now.
Everybody is sleepy now.
Sleepy, you overstepped, okay. So let's take a break, I should say. So,
one question?
One?
Go on. In your one of the slides, you have about something about E2E tests. So,
yep.
You said that mocking only for external APIs.
Yep.
What do you mean with by external? Is it not in your hands or under your control, or is it?
Yeah. So what we try to achieve with our tests is we try to simulate reality as close as possible, but on the other hand, try to make the tests stable, and that is an inherent conflict you need to solve to some way or the other. And the way we try to do this is we try to always cut at the external point, so that means when we do an HTTP request, or when we send an email, or when we read an external data source for some reason. And then this point is actually where we mock the system, or the external world, so to speak. But other than that, we still try to test as much as possible through the stack. Because this tends to find the bugs which are hardest to catch, which exist because two parts don't really fit together very snugly. And these are issues you won't see if you just test one component or the other. That does not mean that unit tests are worthless. They are very valuable, especially if you create algorithms, then they are the way to go. But I see unit tests more as a mechanism for like the individual quality control of each developer, and the end-to-end tests is what keeps your system running in the long run. Another question?
There in the first row.
I have a question specifically for the situation where you are working in small teams and or you are working on a solo project, something that you are learning or like learning a new thing. In that situation or in small teams, how can I find out that the quality of code that I'm writing is up to a certain standards? Do you have any tips for that?
Well, I think I personally don't use like these standardized metrics for code. Of course, you can look into like lines of code, complexity metrics, and so on, but they are just like abstractions of the actual code. So what I try to recommend is sit together and discuss code. And this way you will notice especially if like you go to your colleague and you say, well, please, here, this is my code I created, and then let the colleague navigate it. And then you'll see, is he like, what the hell is this doing, you know? Or is he, oh yeah, this is doing this, and, here I'm having this detailed question, and this way you'll get a feeling of the code, and you will also synchronize. So that's like two benefits at once, I would say. Yeah.
Thank you very much.
All right. Then it's
So we have a feature. We have now a break jingle. So let's open up the room, get some fresh air.
until
And 15 minutes again, or 10?
10.
10.
Okay.
10. 10 minutes to go. And then there's Andre, not Sebastian.